So coming back to the video, which I was sharing with you. So I will, as I told you that I will in one particular class, I will also discuss regarding the orientation of a building. Okay, the very common good question also, the very common notion, a common idea regarding what should be the orientation of a building based on its various rooms like dining room, kitchen, study room, all these things. So the orientation of a building is very important. Okay, so let us come to the video which I was showing you. So please go ahead.
We're standing on the west side of the house, and you will notice how there are very few windows. There are only really ventilators that punctuate this elevation. That's because this is in a sense the worst side for creating large windows. It becomes very difficult in the summer. It's not got much heat in the winter either. So this is the place where it's best to reduce the windows.
Solar panels.
Once we've got such a reduced quantity of demand, it's possible to think of meeting that demand using entirely renewable energy sources.
Yes, corporate offices, cultural spaces also. Education institutes, IIMs, IITs, they are going for such technology, resource. So it's a sustainable goal number 11, which I discussed in the very first class. 17 sustainable goals, SDG, sustainable development goals. Even it's such a fantastic thing that even recently I found that the Heritage School who organized Saraswati Puja also, in their pandal, they have highlighted the 17 principles of SDG. Those who went at the Saraswati Puja at the Heritage School this year, they will be able to know that even the Sustainable Development Goals is not only popular among the college guys, but also among the school students nowadays. Okay, so it is such an important issue. So coming to the slides. Okay, so I discussed today. I discussed regarding the natural topography. Natural topography, or how much topography that should be covering the area. 15% of the site area, natural topography of vegetation should be there. Either natural topography means the natural existing greenery, trees, indigenous species, plants, or vegetation. If you are separately investing money on gardening, etc., then it's very good. So these are the points that I told you. Next is heat island reduction non-roof. It is another very interesting thing, that is heat island reduction. What is heat island reduction? In rural areas, we have lot of shades. We have lot of shades where the surface area or the surface of the site is getting cooler. But in urban areas, we don't have much shaded area. We do not have much shaded area. The shade is there. So we have so in the areas for particular in a particular city where the greenery is very less, heat island formation is there. What is heat island? An island, so a particular area of the urban city, island is formed where the temperature, the surrounding temperature is getting increased like anything. So heat island formation is a very peculiar and very common problem in urban cities. Okay, and also non-roofing. So heat island reduction and non-leaching. So what is the main aim or intention behind this topic or intention behind this issue? Minimize heat island effect so as to reduce negative impact on microclimate. All these properties or all these points or parameters are there in GRIHA also. I will show you the slides in GRIHA. GRIHA, green rating in habitat areas. GRIHA rating also addresses all these issues. Heat island reduction. Minimize heat island effect so as to reduce the negative impact on microclimate. To reduce the negative impact on microclimate, we have to minimize the heat island formation. So how the heat island looks? Very interesting. It looks like this. So just consider you have a small city, you have a large urban area, and surrounding the urban area there is large vegetation, natural forestry, natural greenery. So in this area, which is a forest of concrete, so little vegetation or evaporation causes cities to remain warmer than the surrounding countryside. So heat is getting heated because this completely paved area, no greenery, nothing. Okay, and concrete absorbs huge amount of heat also, concrete and steel. So a heat island is formed. Urban heat island is formed. Okay. Another picture I can show you. If we compare the rural area and city area also, the urban heat island effects occur. How? Compared to rural area, cities have 3 to 10% hotter, 3 to 10 degree hotter compared to rural areas. So what are the problems? What are the issues which makes difference between them? One is heat absorption and retention. Here, the rural area heat absorption is less because it is greenery, natural soil. There is no concrete paving. Concrete paving, what it does? It absorbs the heat. Now, if you see in the city area, concrete pavings, you go for footpath. In campus area, you see majority of the campus of a heritage of or any institution, they are paved, either concreted or bitumen, something like that. Then another problem, plant transpiration and water evaporation from the soil. In rural areas, plant transpiration, water evaporation takes place, but here no plant transpiration, no water evaporation is available because the surface of the earth is covered. This is layered with concrete, cement concrete, or somewhat bitumen for roadways also, right? And another important problem is water penetration. Because during the rainfall, whenever rainfall occurs, the rainwater penetrates through the topsoil and penetrates deep down into the ground. Because we have natural greenery. But here in our cities, water there is very little water population because here we have drains. There is surface runoff is more. Surface runoff, storm runoff is more. There is no groundwater penetration. The biggest problem here, since in cities, majority of the surface is paved either with bitumen or concrete, the water percolation to the groundwater or the ground, subground or underground is not possible. That is why the biggest problem in urban cities is that the groundwater is not recharged. Groundwater is not recharged, so if you deep down go for boring, you will not find water. Okay, so that is why the biggest another very big problem in cities that the majority of water rainfall goes through the surface or storm runoff or drainage, but not through the normal natural soil of earth. So option one. So what are the options the IGBC have given? High reflective materials. You have seen in the video which I shown you previously, they are using glass claddings and white tiles because maximum heat surface or sunlight rays will be reflected. So high reflective material is very important. You should not use any paint, you should not use any color. or a material which absorbs huge heat. We all know from our childhood days a light colored shirt, a light colored dress reflect heat, while dark colored while dark colored cloths they absorb heat. So it's the same common concept. Use materials with a high solar reflective index. Very important point, index point, very important. Solar reflective index, SRI. Solar reflective index to cover at least 75% of the exposed roof area, including covered parking. 75% of exposed roof area, including covered parking. Whatever it can be, you are using, as I told you, in many cities in Tamil Nadu, I have seen white extra top patch is given on the roof surface to reflect heat. It is keeping 10 to 15 degrees temperature cooler compared to the other structure. Even some of the roads in IIT Kharagpur, if you see there, L&T have used white topping paint, special type of paint, which is reflecting huge amount of heat, and the bitumen of the road is saved because the heat is deflected. Okay, so reflective materials we should be using. It can be paint, it can be tiles. No, material with high solar reflectance index SRI include white or light colored China mosaic tiles or white cement tiles or other reflective materials or coating. We will see in many cities in India, reflective coatings on the road also is used. Mainly in road, it is very costly. It was L&T, not L&T, Ultratech. I'm very sorry, Ultratech did a test experiment on a particular stretch of road in IIT KGP campus, and they observed that huge amount of heat is being conserved or heat is saved. Similarly, so as a human being or as a normal citizen, what can I do? I can give a white coat paint to my roof, where because if you go to the topmost floor, those who stay in topmost floor of the flat or residential building, they feel the maximum heat because throughout during the day, the heat of the sun is absorbed. So that can be reduced. Okay. Very interesting, very common sense, very common practical things which are there. Okay, so we can reduce the heat island like this. Another diagram here we can see heat island phenomenon occurring. How? See, we can from the trees temperature goes down, heat of vaporization. Heat from the road surface, heat from the vehicles, obviously a big issue. Large number of vehicles are increasing day by day, private vehicles on the road. So the heat from the vehicles, heat from the machinery, heat which is coming into the auto ACs. So heat from vehicles, temperature is rising. Temperature increase from buildings also. So these are all these issues. How the heat island phenomenon is occurring. So solar reflective index SRI value for different roof types. If we are using low slope roof, where slope is less than 2:12, means 1:6 actually. Low slope roof, minimum SRI value is 78. Low slope roof means minimum which are flat roofs particularly. Steep slope roof more than 2:12, 29 minimum SRI value should be adopted. Okay. Now points. Coming to the points about it. If we have reflective material, percentage of roof area covered more than equal to 75%, then 1 point. More than equal to 95%, 2 points. Okay. So another very big issue which can help you to gain more points, like if you cover majority of your roof with solar panels, that is acting two ways. One, it is reflecting the heat, and also it is absorbing the heat from the sun and converting the solar energy into electricity. Okay, so all these things. Outdoor light pollution reduction. Okay, outdoor light, we can also reduce the outdoor light pollution. Light pollution is also very big issue Many governments, state government, they don't understand that unnecessary lighting is also creating havoc. It is not increasing the aesthetic of our city. It is rather destroying the money of our common mass, destroying the natural ecosystem, harming the surrounding environment by light pollution. Many state governments, they don't understand this. Unnecessary huge amount of lights. You know, Trifala light is there throughout our Kolkata. Unnecessary lighting, huge amount of light, absolutely not required. They basically indirectly increasing the surrounding temperature also. People don't understand this. That is the fallacy of educated people and uneducated people. I mean, Joe Jobosty, I'm forcefully implementing huge amount of, for example, staff light, street lights, or floodlights in my campus. For example, my campus is around 1200 square meter, and I'm putting up one huge floodlight. It is giving light to the campus, but it's unnecessarily increasing the light pollution also. So the intention or the aim should be reduce light pollution to increase the night sky access and enhance the nocturnal environment. Night sky access means people can see the night sky clearly and enhance the nocturnal environment. Means the night environment would be present because there are a lot of creatures, lot of birds, a lot of animals who go to sleep during the night. So the nocturnal environment should be preserved. The night environment, simple. See, one case study I've taken from a news department of energy to 2011 data. Energy wastage, what the light pollution is costing us. See, USA states are very much advanced compared to us. Okay. We have an energy building code also. I will discuss this EBCC. It is from our Indian standard. EBCC energy building code where energy efficiency is being addressed. Okay. But huge study like this, they don't do. So 30% of residential electricity used in the US for outdoor lighting, they are creating pollution. See, bad outdoor lighting wastes 0.5 kilowatt hour of energy per house per night, which is equivalent to 0.5 kilowatt hour of electricity, enough energy to power a 50-inch plasma TV for 1 hour. So energy wastage can be implemented, it can be saved. Everywhere we should look for saving, okay, not wasting, but saving. We should look for in construction site also. We should always look for saving. See, CO2, about 15 million tons of CO2 are emitted each year in order to power residential outdoor lighting in the US. Residential outdoor lighting means lighting in the park, lighting in footpath like this. About 3 million passenger cars have the same CO2 emission. So on next day, I will show this, I will extend with this video, I will extend with this presentation, but let me show you one video. See, green building, yeah. Let me show you another video. How energy efficiency is implemented.
Every country needs energy for its development and economy, and the same is true for India. Additionally, India is a developing country with large ambitions, and the energy consumption in India is expected to double by 2030. India's climate change policy document talks about the need for energy efficiency and the role it can play to significantly reduce its energy intensity by up to 33%. energy sufficiency and energy efficiency are very closely intertwined. At AEEE, we believe that energy efficiency is the cheapest, fastest, and cleanest resource to make this energy transition. This office was designed using AEEE's lean, mean, and green strategy. At the start of the design process, AEEE design team made a very conscious and deliberate effort to reduce our external heat gain, maximize daylight, and bring in fresh air. I would like to express my sincere and heartfelt thanks to MacArthur Foundation for their generous support which made this office possible. Saint-Gobain, which has played an instrumental role in supplying these double glazings which reduce cooling load inside the office while maximizing the daylight. A carefully selected option of U value, solar heat gain coefficient, and visual light transmittance helps achieve this design goal inside this office.
Well-being and sustainable development are two important priorities for Silverman. In AEEE, we see a platform of like-minded people to take the journey forward in India.
It is with great pleasure that we are partnering with AEEE, and there is a reason for that because we share a common vision. We are not only propagating new technology of lighting which is going to be much more energy efficient and much better from a well-being standpoint. We are also walking the talk by clearly taking upon ourselves to be carbon neutral by 2020.
What we have done in this office reflects our commitment and our passion to coming up with the right kind of air conditioning solutions. The installed VRF system is among the most energy efficient air conditioning system that is available in India right now. The ventilation system has been specifically designed and integrated with the VRV system to address the air pollution and Delhi's compromised air quality by ensuring that the particulate matter and the CO2 levels inside the office building are within acceptable standards. To showcase our belief in adaptive thermal comfort, where we integrate an active air conditioning system with the deployment of super energy efficient fans provided by Atomberg. They use a technology called brushless DC motor, which allows them to reduce the energy consumption by up to 50%. We have used technology provided by Siemens and Honeywell to ensure that a well-designed and well-executed energy management strategy starts with proper sensing, instrumentation, and metering technology. This feeds our central controlling unit and it keeps our office CO2 and humidity levels both under check and under constant monitoring conditions. An Acti9 SmartLink is the mind of this system. The little devices which are called power tags, these are the ones which are aggregating the energy consumption and all the electrical parameters, and through the remote monitoring capabilities of this SmartLink system, they are beaming the information to the building management system. Each of these is separately monitored and we can track and benchmark the energy consumption at the system level, at the component level.
At Schneider Electric, we believe that energy efficiency is a cost-efficient, cleanest and most abundant source of energy. I'm delighted that we have a partner in AEEE which shares our beliefs and is committed to this cause.
I believe with this new office design, AEEE is going to lead by example towards enabling an energy efficient India.
So this is how the AEEE is a very big council in India. They promote the energy efficiency sector. See, various companies are there. If I come to this, Yeah, if I show you this, that is the various companies, they come forward without the entry of big companies. It's not like Atomberg. Atomberg, if you know, Atomberg company is very good company. They provide automated ceiling fans. ACs, then ceiling fan with remote sensor. Atomberg, you see in the TV ads are there. Atomberg, fans of Atomberg during the summertime, the advertising comes. Okay. Carrier, you know, a very big company of AC. Schneider Electric, we have an office in Sector 5. Those who go through the through Technopolis from Ruby area or from the towards Technopolis, we have a Schneider Electric office at Sector 5. Saint Gobain, another very big company of glass. We have also, I have a friend who works at Fenesta, a very big company, glass company, who are coming to Siemens, you know, very big company, electrical company, electronics company, Siemens. So they come forward to bring out this energy efficient system in India. Okay. So with this, I want to end today's class.
Yes, sir.
Thank you. You can exit.